Hello, I'm Aaron Sledge, and here in Mech Lab 115 today, we're working on Lab 3 on variable resistance. Intro on week 3. This lab is to assemble a circuit that controls the speed of a DC motor and to use the multimeter to find the voltage readings at various times throughout our lab. With the help of header pins placed in the correct position, the correct area assigned to explore the findings of volt drop, amps, and resistance, controlled with a component called a potentiometer. Equipment today will need Arduino for our 5-volt power supply, breadboard here, a DC 7.5 toy motor. I don't know if you can get that. 10,000 K potentiometer, 3 single header pins, 3 jumper wires of different colors, installer's choice, a multimeter to do the readings, and a sketch of the motor circuit, which is here. We've got positive coming out, our header pin, potentiometer, another header pin to take another reading, positive side of the motor, negative side of the toy motor, header pin 3, back to the Arduino. And then our graph here, I've pre-filled out some numbers because I did a lot of the numbers prior. So we'll go over those here in a moment. So we will procedure, construct the circuit by following the diagram using a breadboard, potentiometer, and various colored wires, toy motor, and making sure the header pins are properly located, like I said again. Once the circuit is assembled, we're going to go ahead and plug our power in. At this time, with the positive being connected to the potentiometer and the negative to the other side of the motor going through the circuit, motor is now on what I believe full blast. We're going to go ahead and take a reading from the pin number 3. We have pin 1, pin 2, pin 3, and power coming straight off the Arduino. We're going to take that measurement first. We are reading 4.995-ish. The second reading is going to be from negative to pin 1. We are reading 5.72, going up to 6 even. From pin 3 to pin 2, which is getting closer to the motor, is 6.47. And then from pin, just because I wanted to do it, and it was an interesting find, which is interesting because I've had some other numbers that were actually all the way up in the teens on this pin before. It's reading different now. So from there to the motor, I'm getting 6 to 8 volts, now dropping down to 5 coming off the motor running. So from there, we're going to shut it off all the way. Our circuit's still complete, but the potentiometer is just powered down. At this point, we're going to take pin again to the hot on the Arduino, 4.99, and then we're going to go to pin 1 from pin 3 with a negative, 0 readings, and then from pin 3 negative to pin 2 positive, 0 readings, and then again to motor positive, 0 readings again. So now, after writing those down, I'm showing a resistance of 9.75 on when it's powered off. We're now going to turn the potentiometer up on just to where the motor's barely moving. And you'll just barely hear it. It kind of sounds like it's angry. And my potentiometer is very touchy. Within 1/8 of an inch, it's either barely on or all the way on. So I think you can hear it. It's moving very slowly. We're going to start over with our measurements again from pin 3 on the negative to the Arduino power supply is 4.99 again. And we're going to jump from pin 3 negative to positive pin 3 1. We've got 1.3 volts. And then from there to pin 2 is 1.326 or 29 volts, fluctuating back and forth. And then again to the motor is 1.29. With a resistance of about 1.6. And then from there, we're going to turn it on just a little bit more. You can hear the motor fire up a little bit more. It's probably a little bit more happier. It's getting some more power. Sorry, bear with me. Okay, I'll go back through the numbers again and record them on the chart. We're going back to Arduino again, 4.99, pin 3 negative to pin 1 positive, 1.25. I'm going to turn that up just a bit. It's very touchy. There we go. Let's try that. Pin 1 again. 1.67. Pin 2 positive. 1.68. And then to the motor, positive is 1.63. And that gives us a resistance of about 0.09. So turning it up another stage, but not quite all the way up yet. Motor, you can still hear it. Again, back to the same numbers, same pin. Arduino still reading 4.98. Negative pin 3 to positive pin 1 is 4.5 to pin 2 positive. We're reading 4.57, and then to positive motor is 4.78. And then turning up all the way now, you can hear the motor go even louder, which wasn't a whole lot more up. Again, we're going 4.9 from Arduino. Let's see if we're reading 5 points down. And then to pin 1 positive, we've got 7.4 highest reading. And then to pin 2 positive, we're reading 7.3-ish to 8. And then to the motor, it's going from 6 to 9 to 10. Which is interesting, again, that it's jumping that high. I'm going to go ahead and disconnect the motor. Resistance on the highest is 0. The next highest, the second to the last measurements, it was 0.01 resistance. As far as results, it was interesting that I'm getting more power once this is up all the way than the Arduino is actually supplying. So that tells me that this is actually creating some power. I don't know what that does to the Arduino. If the Arduino blocks it from going back in, I'll look further into that in the future. We've got basically the analysis is it's interesting on the parallel on the circuit that potentiometer is able to adjust, and that it's that fine of an adjustment. It's literally just after this thing going a whole 180 degrees, it's the last 1/8 of an inch that controls this little motor. It's kind of small down in here, but in conclusion, thanks for your time. Have a good day.